Hi students, welcome back to Let's Get Mental. We're moving on to another grade 7 topics, which is called numeric and geometric patterns. So patterns in general, but we have differences between the geometric and the numeric. So let's move on to our lesson objectives. What are increasing and decreasing patterns? What are the differences between a numeric and a geometric pattern? What is a constant difference pattern and what is the constant ratio pattern? How do we use a rule to extend patterns? And finally, how to find the formula of a pattern. Increasing patterns. So an increasing pattern shows a growth in our pattern from one number to the next. So if you look at the example, we've got 15, 30, 45, 60, 75. So in this pattern, you will notice that it's increasing and that the number is increasing by 15. So we say the number pattern is increasing by adding 15 from one number to the next. So as you can see, the number pattern is adding 15 each time. Okay, decreasing patterns. A decreasing pattern is the opposite of an increasing pattern. So we see that it is actually reducing in its numbers, and so the decrease is showing that there's no growth. It's actually going down. In your example, you see they have 75, 65, 55, 45, then 35. If you see this pattern, you can see the numbers are decreasing each time and is decreasing by 10. So in this pattern, we say it's a decreasing pattern and it's subtracting 10 from one number to the next. Okay, now we're on numeric patterns. So there's different types of patterns. You get numeric and geometric. So we're going to focus on the numeric first. In the example, you see an example we already went through, which was the decreasing pattern showing 75, 65, 55, 45, 35. So we can see that this pattern is made up of numbers only, and so it's called a numeric pattern. So once you see numbers, you got to know that these are number patterns and they're called numeric patterns. If you see any symbols and shapes, it would be not a numeric pattern. So in this example, it's a decreasing numeric pattern. Then we move on to geometric patterns. So if you see this pattern is so much different to the one we've seen. The previous one had only numbers, and here we see a bunch of dots. So geometric patterns is made up of shapes and symbols that you will find in a pattern form. So in this one, it's showing pattern of dots that are increasing from each term, from one term to the next. So the first one shows you one dot, second one has 3 dots, the last one has 5 dots. So we can see it's an increasing pattern, and so we say this is an increasing geometric pattern. Okay, so now it's your turn to try and explain the pattern. So look at the pattern and describe it in words. So I've given you like a breakdown of how you should word your pattern. And in each example, you've got options in brackets. So you need to pick and choose what type of pattern you are seeing in each example. Choose your answers and then come and look at my actual answers. So here's the answer. The pattern is a geometric pattern. We can see there's only shapes and symbols. There's no numbers. So this pattern is an increasing pattern. Can you see from the first term to the second term and then to the third, there's an increase of one triangle each time. And so it shows that the pattern is increasing, adding one triangle from each term or at each term. Now try to explain the next pattern. So you've got another pattern in front of you. It looks different to the previous one. So now you're going to explain what is supposed to be filled in each of my blanks. So I've got there, the pattern is a something pattern that is something by something something digits, each time from the previous something. So you need to know what fills in each of these spaces. Take a few minutes, try to fill in what you think would fit in those spaces, and then come look at the answers. So here we have the answer. To explain the pattern, we can firstly see that there's no symbols and shapes, and so this is a numeric pattern. The digits are a clear example that it's a numeric pattern. So the pattern is a numeric pattern that is decreasing by subtracting 6 digits each time from the previous digit. So if you see between each number, there's a difference of 6. And that's how we arrived at subtracting 6. And also identifying that it's a decreasing pattern instead of a increasing pattern. So what you need to know in each example is whether it's firstly a numeric or geometric pattern, whether it's an increasing or decreasing pattern, then whether it's adding or subtracting, and by how many digits or symbols. So very simple, very few differences that you need to identify before you actually put into words. So next we're moving on to constant difference pattern. These are when patterns have a constant value, either adding or subtracting from one term to the next. So if you look at the example, we've got 75, 60, 45. This is a numeric pattern that's decreasing, and the constant number that is decreasing by is 15. And so we call it a constant difference pattern. So any pattern that you see has an addition or a subtraction in the difference of how it reacts between terms, then it's a constant difference pattern. Let's move on to more examples. So we have two geometric pattern examples here for you. So the first one shows the geometric pattern that is constant in the way it subtracts one triangle from the term 1 to term 2 and then to term 3. Terms is basically from one pattern to the next pattern and the next. So you can see this subtraction and it's subtracting by one triangle, so we call it a constant difference pattern. The bottom one has dots, and the dots is increasing from one to the next. So we've got 1 in the first pattern, then 3 dots, then 5 dots. So it's showing an addition pattern of 2 dots being added each time. So this is also a constant difference pattern. So always remember, constant difference patterns have addition or subtraction happening between terms. Then we move on to constant ratio patterns. This is also showing pattern value as constant, but in the way it multiplies and divides between numbers. So if you look at the pattern here, we've got 2, 4, 8, 16. So in that pattern, you can see from 2 to 4, we multiplied 2. From 4 to 8, there was a multiplication of 2. And from 8 to 16, another multiplication of 2. So this pattern is multiplying by a constant number of 2. We call it a constant ratio pattern. So we're going to look at more constant ratio patterns. In the first one, it's a numeric pattern, and in your second one, you can see there's a geometric pattern. So in the first one, we've got 64, 16, 4, and 1. Now, if you notice, between each one, we are dividing 4. So from 64 to 16, there was a division of 4. From 16 to 4, we divided another 4. And from 4 to 1, we divided 4 again. So this number shows dividing of 4 each time from one term to the next. And so we call it a constant ratio pattern. Remember, constant ratios have multiplication and division in their pattern differences. Then we look at the bottom one. The geometric pattern is constant in multiplying 2. So from number 1, the first dot, multiply 2, you get 2 dots. From your second term, the 2 dots, we multiply 2 and we get 4 dots. So the multiplying pattern is by 2, and so we call this a constant ratio pattern as well. Now you determine the differences between constant ratio and a constant difference pattern. So in this examples, take a few minutes, have a look at it and see whether it's a constant difference or a constant ratio pattern, and then come look at the answer. So if you look at the first one, you've got a numeric pattern that is constantly subtracting by 5 each time, and so we call it a constant difference pattern. The second one, you can see there's dots, and the dots are also subtracting or dividing, by 3 each time, and so this is a constant ratio pattern. Let's use rules to extend patterns. So we are going to start with the number 15 and extend the pattern by 5 numbers using the rule plus 10. So if you see, I've got it laid out where we start with 15, we've got 5 numbers that we need to fill in, and in each step we need to add 10 and add 10 for each term. So you can pause, you can try it, then look at the example answers. So the answers here are, from 15 we're adding 10 to get 25. Then from 25 we add another 10 and we get 35. From 35, we add another 10 to get 45. From 45, we add another 10 to get 55. And finally, from 55, we add another 10 to get 65. So can you see the rule had started with, the pattern had started with 15, and we added 10 for 5 different spaces. So 5 numbers needed to be filled. So when we added 10 each time, these are the results we had. So this is the pattern showing a rule of 10 starting with the number 15. I hope that makes sense to you. Let's use the rule to extend more patterns. So this time you're starting with 3 and you will extend your pattern by 4 numbers using the rule times 2. So take a moment, work out the rule times 2 each time, starting with 3, and then come look at the answer. Okay, now for the answer. So we started with 3, we extended our pattern by 4 numbers, and we used the rule times 2. So if you did this, you would have arrived at 3, 6, 12, 24, and 48. If you got this, good job. You understood the activity. To explain to others, 3, we multiplied 2, we got 6. From 6, we multiplied 2, we get 12. From 12, we multiplied 2, we get 24. And for 24, we multiplied 2 to get 48. Now try extending another pattern. So this time you're starting with 18, you're extending your pattern by 3 numbers, and we're using the rule plus 6. Take a moment, pause the video, try your 3 numbers, and then come look at the answer. So here are your answers. We started with 18, and the 3 numbers would be 24, 30, 36. If you got that, good job. Now we have a challenge. So in this challenge, you're going to get a little bit of all the points that we just covered in numeric patterns and geometric patterns. In this example, you're working with a numeric pattern. We've got 3, 23, 43, 63, and we've got blank spaces. So number 1 wants you to explain the pattern in your own words. For number 2, it's asking you, is the pattern a constant difference or a ratio? 3 is asking you to extend the pattern by 2 more digits. Pause the video, take a few moments, then come look at the answer. So in your answers, your number 1 would be it's a numeric pattern, and the pattern is increasing by adding 20 digits from the previous term. Number 2, it says it's a constant difference pattern, and this is because we see it's adding 20 each time. Number 3, the next 2 term numbers, if we added 63 to 20, we would have got 83. And from 83, we add another 20 to get 103. So if you got those answers, good job. Now we're moving on to finding the formula of a pattern. So this is a little bit tricky because you need to know more terms in this example. So I'm going to explain firstly what are the steps that we use to find the formula of a pattern, and then we'll use an example to understand it better. So formulas are written in algebraic expressions or equations where there's a variable that describes the unknown number in the sequence. So in both geometric and numeric patterns, you will be able to find your formulas using 3 simple steps. So A, you must find the common difference between them and multiply it. B, it says we must compensate by adding and subtracting to arrive at the output number. And C, finally, we must test our rule with at least 3 terms to prove that it works. So I have an example for you. The formula is given as 2n minus 1, and we need to look at the pattern. So our pattern shows us term numbers on the top. So term 1 shows us there's only 1 dot. Term 2 shows us there's 3 dots. Term 3 shows us 5 dots. And term 4 shows us 7 dots. So firstly, in our steps, we need to determine the common difference. So if we looked at the dots and how it was increasing each time, we see there was 2 being increased each time. So the number of dots added on each time was 2. So we take the 2 and multiply it with the variable. And so in our formula for the first part is 2n. A variable can be any number. So you could use any letter in that position, and that letter would stand for your term numbers. So like your term 1, your term 2, 3, 4, 10, 12, and so on. B asks us to compensate to get to the outcome. So in term 1, we've got 2n, and it says 2 times 1, which gives us 2. We have to do something to arrive at the output, which is 1. And so minus 1 fits this formula perfectly. Finally, we need to test it with at least 3 terms. So in my next page, we're going to test it. So the formula again shows you the 2n minus 1. We have the pattern for you so you can understand it better. It's time to test the formula. So the formula 2n minus 1 should work for this pattern, and we are going to test it for each term. So if you look at term number 1, wherever you find your variable, you're going to put in the term number. So term number 1 shows us 2 times 1 minus 1 would give us 1 dot. So 2 times 1 gives us 2, minus 1 gives us 1. In term 2, we've got 2 times the term 2 now, which gives us 4, minus 1 helps us to arrive at 3 dots. In term 3, we're using the formula 2 times 3, which gives us 6, and we minus 1 to get 5 dots. If you would like to test it further, you could go with 2n and test it on the 4th term. So if we said 2 times 4, which gives us 8, and we minus 1, we'll arrive at 7 dots. So can you see that that formula that was given to us actually does work for this pattern? Let's move on to another example. So here we've got another formula given to us, and it is 4n plus 5. This time we've got a numeric pattern, and in the term 1 it shows us 9, in our term 2 it shows us 13, in our term 3 it shows us 17, and in term 4 it shows us 21. So in this numeric pattern, the common difference you can see from 9 to 13, 13 to 17, and 17 to 21 is actually 4. So we take that 4 and we multiply it to our variable, and so we get 4n. Secondly, we must compensate by adding or subtracting at the first term to arrive at the outcome. So our first part is 4n. We need to find out from multiplying 4 times 1, how do we arrive at 9? And so the only difference we have is plus 5. So plus 5 becomes our second part of the rule. Next we need to do is test that it's actually going to work for each term. So let's do the testing in the next part. So testing it against each term. For term 1, we're going to use the same formula, 4n plus 5. So term 1, 4 times 1, which gives us 4, plus 5 gets us to number 9. So it works in the first term. Term 2, 4 times 2 gives us 8. If we add another 5, we're going to arrive at 13. So term 2 works perfectly. Term 3, we're going to multiply 4 times 3 to give us 12. And if we add 5, we arrive at 17. So we see that the formula has worked perfectly. It's time to now test it against the 10th term. So use the formula to find the 10th term output number. Now in our current pattern, we don't see the term 10. But if we were to figure out what the term 10 would be, all we had to do is take the formula and work that out. So in term 10, wherever we find our variable n, we're going to fill in the term 10. So 4 times 10 would give us 40, plus 5 would give us 45. So our term 10 would have the output of 45. Now it's your turn to try finding the formula of these two patterns. Now, it does seem complex, but break it down. You've got 3 simple steps. So A, you're going to find the common difference and multiply it to get your first part of the formula. Then you will compensate using plus or minus to get the balance of your formula. Once you have the both parts of your formula, you're going to test it against term 1, term 2, and then term 3. If each of them gives you the right output, that is your formula and it is proven to work. Finally, all you'll have to do is find term 4 by using the formula and filling in your term 4. So try that. It may take a bit of time because you're still trying it for the first time. Don't be hard on yourself. Take it easy. Then come back and look at the answer. Right, so now we have the answer. The pattern 1 formula was 6n minus 2. So if you managed to get that, good job. How did we get there? We looked at the common difference between 4, 10, and 16, and so it was 6, and we multiplied that by 6. So 6n is your first part. Then we tested number 1 to compensate how we got 4 as your outcome or output number. So with term 1, we put 6 times 1, which was 6, and we had to find out how we get back down to 4, and so it was a subtraction of 2. So that's how we got the second part of the formula. So 6n minus 2, we tested it on term 1. 6 times 1 gives us 6, minus 2 gives us 4. In term 2, 6 times 2 gives us 12, minus 2 gives us 10. Then in term 3, 6 times 3 minus 2 gave us 16. And then to find the fourth term, we put it into the formula. 6 times 4 gives us 24, minus 2, we arrived at 22, and that became our final missing answer. So if you did this and you succeeded in all parts, good job to you. Let's move on to the second pattern. So in pattern 2, we said it was a geometric pattern. This formula read as 3n plus 1. So if you had that, good job. Let's test it on each term. Term 1, we had 3 times 1, which is 3, plus 1 gives us 4 sticks. In term 2, we had 3 times 2, plus 1 gave us 7 sticks. In term 3, 3 times 3 is 9, plus 1 gives us 10 sticks. And finally, we have term 4, which is 3 times 4, making 12, plus 1 gives you 13 sticks. So in the final step, you would have to draw it in your geometric pattern, and so I've put it there in green, and you should have 13 sticks when you count them. Right, so that is the formula and how to find the formula. If you need a recap on any of the points, you can go back and figure out your tips and the steps that you need to cover so that you can successfully complete all of your tasks. I hope this video has helped you. I would like to say thanks for watching, and like, share, and subscribe, and I will see you in the next one.